name's Kurt Kaler. Oops, sorry. Hello, my name's Kurt Kaler, and I'm the founder and president of AlGalCo, the aluminum gallium company. We wanted to give you an idea of where we are in our progression and the development of this technology of making hydrogen on demand from aluminum and water. So this is what the alloy looks like. It's 90% common aluminum. So it's highly exothermic and it's very dynamic reaction. So this is just a typical 100-gram button of our alloy, and this is just typical water. When you add, you'll see that it instantly makes hydrogen on demand. So you're dealing with a highly exothermic reaction. So we'll leave it in there and we'll show you what it looks like in a couple minutes when it reaches its maximum. So this is where we started with the original alloy. So now we have progressed to the point where we put it into several different systems and installed it on fleet vehicles. So I wanted to give you an idea of how that has progressed. You'll also notice that when the alloy reacts with water, it spalls. It takes up a lot of volume with the alumina or aluminum oxide, and that gets very hot to the touch. So we need to recover this alloy or this alumina from the alloy so we can recycle it. So that was part of the thinking of how we put the system together. So this shows the progression. This was our prototype, these two tanks. So you have 600 pounds of stainless steel. We put the alloy inside of it, react all the water all at once with the alloy to make hydrogen, feed the hydrogen into the intake manifold. So we did a year of testing with this. Version 2.0 was this tank and this tank. Another year of testing. Version 3.0 was just this. And this is when we started to use the tank within a tank. And then the version we have now is version 4.0. Now the weight has gone from 600 pounds on the prototype down to 120 pounds on version 4.0. We made several 4.0 versions and we sold it to the people from Carmel, Indiana, as well as the town of Noblesville, Indiana, and Fishers, Indiana. Then we stopped because we are trying to get to a version 5.0 that we think will take out a tremendous amount of the cost. So the way the system works, and we'll keep part of this system with 5.0, is we'll take the alloy, we place it into the bottom of this tank, and we put 900 grams, so about 6 of those buttons. Then we put this assembly in here, and then we put the lid on. So that's how 4.0 works. Now we have always, our philosophy has been that we have the alloy inside, water in the outside jacket, and then the water will enter inside the container and then reacts with the alloy to make hydrogen gas, which then exits and then follows its way into the intake manifold. What we want to do on version 5.0, and where we think the cost savings are, is instead of having the alloy and add in the water, we want to have the water and add the alloy. So if we are successful in doing that with version 5.0, then what that means is this assembly goes away. Because we fill this full of water, 7 liters of water for 900 grams of alloy. So this will put air over water so that we don't have to have a pump. So this, but if we do it just with a reservoir of water and then like an Archimedes screw that will put the pellets into the water here, we don't need this high pressure. So this assembly would go away. This assembly here would also go away. This is how we refill with water in the outside. That won't go. That can go away because we don't need to have high pressure or an ASME coated tank. This assembly goes away because I don't have to take the water from the outside jacket up to the inside. So this all also goes away. So the water here comes up from the middle. But we like the tank within a tank because when the alloy is all reacted and becomes that powder, the aluminum oxide, then we like to be able to quickly pull it out, put a new system in, full of fresh alloy, fresh water, and that's part of the refueling process. So we like to do this without having it under high pressure, but still keep the tank within a tank, so we're able to take this out quickly and exchange it when our customers want to refuel their vehicles. So if we can do it with a reservoir of water and just add the alloy into that as we need it, then that's going to get rid of the need for ASME code. It also takes a huge chunk of the weight out. So, and also gets rid of every assembly except this one, because the hydrant will still exit, and a pop-off valve that we put in here just in case. So this is the only thing we would need to keep. All this goes away, and the need for a code. So that's the idea. That's why we're talking to you for a 5.0, is because we wanted to give you an idea how the alloy reacts. Highly exothermic, generates as much heat as hydrogen, and our current system 4.0, and what we perceive as to be the value in having a cost reduction with a system 5.0. So if we're lucky and we can do it with PVC on the inside of the container, and then some kind of aluminum or stainless steel casing on the outside for weather and those purposes, take a lot of these assemblies off, then we think we'll have a version 5.0 that will be able to really sell. The 4.0 was sold out in 3 weeks, but we think the 5.0 with the big cost reduction and further weight reduction, especially from 600 pounds to 120 down to whatever we think 5.0 can do, it will be very significant for us and will definitely increase our exposure. So we just wanted to give you a feel, because we would like to have the alloy tested with the 5.0 system if possible. So we'll look to our truck. It's a standard F-250 here at the Como Garage. It's a 5.0-liter Triton V8. So we'll take you around to how the system is mounted now, so you can get a feel for how we did that, and see if there's any ideas you have that would make that a better process as well.